Question 17 is asking us which of the following pairs of lines intersect and which do not. And then for those that do intersect, it wants us to find the coordinates of their point of intersection. So this is quite a long problem, and so I'm going to just do about half of these questions so that hopefully from that you can figure out how to do the rest, because they're all pretty similar and you can take a similar approach to answering them. So the ones I'm going to do are A, C, E, and G, and so hopefully from that you can get an idea of how to do this type of problem. And so for question A, this one's actually quite nice, because if we look at it, we can see that both of these lines are in the form y equals mx plus b. So we can see that the slope of both of them is the coefficient on x. So the slope for both is 2. So these lines have the same slope, which means they're parallel, and that means that they do not intersect. For question A, the answer is that they do not intersect. So if we look at the rest of these equations, and we look at the coefficients that are on x, we can see if the slopes are the same and whether or not these other equations will intersect. So in question C, in the first equation, we have a positive 1 as a coefficient on x. And for the second equation, we have a negative 1 as a coefficient on x. So these are different coefficients, therefore different slopes. And so these lines aren't parallel and will therefore intersect. In question E, again, we have different coefficients on x. These equations aren't in the form y equals mx plus b, but if we kind of imagine how we'd solve for this, we can see that we're going to end up with different coefficients on x, and therefore these lines will intersect as well. Question G is a little bit harder, and we'll have to rework that one to put it in the form where we can see that our slopes are not going to be the same and these lines will intersect. For all of these, we can also just start trying to solve for x and y, assuming that they intersect, and if they don't intersect, if they are parallel by some chance, then that system just won't work out. Okay, so moving on to C. The way I'm going to do this one is that we have two expressions for y in terms of x, and I'm just going to set them equal to each other, because we know that the point where they intersect will have should have the same y value. So for C, what I'm going to do is say that x equals 5 should be equal to 5 minus x at the point where these lines intersect. So I have x plus 5 equals 5 minus x. And now I can solve for x, and to do that I'm going to add this x to both sides of my equation. This gives me 2x plus 5 equals 5. And now I'm going to subtract 5 from both sides. This gives me 2x equals 0. So dividing by 2 on both sides means that x is also equal to 0. So now I can take this x value and plug it into either one of these equations. I'm going to pick the first one. So this gives me y equals x plus 5, and I'm plugging in 0 for x. So I have y equals 0 plus 5. This gives me y equals 5. And then So to check this, it's a good idea to plug these values into the other equation. Just for time's sake, I'm going to leave it at that. So this, for part C, my answer is that the coordinates of their point of intersection are at x equals 0 and y equals 5. All right, so moving on to part E. In this question, what we can do is actually get rid of one of our variables by adding our two equations. So I'm going to rewrite this here. 5x minus 3y equals 9, and 2x plus 3y equals 5. And so if I add these two equations, 5x plus 2x is 7x, negative 3y plus 3y is 0, so that disappears. I get 7x equals 9 plus 5, which is 14. Now I can divide both sides of my equation by 7, and I get x equals 2. So now what I want to do is plug in this value for x into either one of these two equations. I'm going to pick the bottom one. So my bottom equation is 2x plus 3y equals 5. And so it gives me 2 times 2 plus 3y equals 5. I'm just solving for y here. I have 4 plus 3y equals 5. And I'm going to subtract 4 on both sides. This gives me 3y equals 1. Dividing by 3 on both sides gives me y equals 1/3. Again, it's a good idea to plug these values into both equations, make sure they work out, but this is the right answer, and it's the point of intersection is x equals 2. All right, it's x equals 2, y equals 1/3. And I think maybe with the solutions you've been given for this homework, the answer for this question might be wrong, and I think it might be have a value of 1/2 for y, but you can see that when we plug in this point for these two equations, this is the right answer. So moving on to part G, I've just copied it down so I have a little bit more room to work. This one's a little bit messy. We have a fraction in the first equation, so the first thing I want to do is rework that first equation to get rid of that fraction. So I'm going to rewrite it down here. Y minus 2 over x plus 3 equals 4. And what I want to do is multiply both sides of my equation by x plus 3 to get rid of it on the bottom there, and that's going to give me y minus 2 equals 4 times x plus 3. And multiplying that out gives me 4x plus 12. And next thing I want to do is subtract my 4x on both sides of my equation. And this gives me y minus 4x minus 2 equals 12. So what I'm doing here is trying to get it into a similar looking form as the second equation. So then we can set them up and hopefully add or subtract to get rid of a variable between the two equations. So the next thing I'm going to do is add 2 to both sides. I have y minus 4x equals 14. And so now this is in a similar form as the second equation. I'm just going to change the order of these It's the same thing as negative 4x plus y equals 14. So now what I'm going to do is take these two equations, negative 4x plus y equals 14, and I want to get it so that one of my variables disappears when I add or subtract these. So what I'm going to do is multiply this entire top equation by 4, and that's going to give me 4x that can then cancel out with the negative 4x. So multiplying by this by 4 gives me 4x plus 28y equals 1. And I'm going to take this bottom equation as is, plus y equals 14. And so with these two, I'm then adding them. So 4x plus negative 4x is 0. 28y plus y is 29y. And 1 plus, sorry, this should be a 4 up here, because I've multiplied that 1 by 4. So this is going to be actually 4 plus 14, which is 18. And dividing by 29 on both sides gives me y equals, I'm just going to leave this as 18 over 29. Doesn't simplify any more than that. Okay, so now what we can do is plug this in for y in one of our equations and solve for x. So I'm going to take this one, x plus 7y equals 1, and plugging in 18 over 29 for y. And so 7 times 18 is 126 over 29. And I'm going to subtract 126 over 29 on both sides of my equation. So this gives me x equals 1 minus 126 over 29. And 1 can be rewritten as 29 over 29. I'm subtracting 126 over 29. So 29 minus 126 is negative 97 over 29. So I have y equals 18 over 29 and x equals negative 97 over 29. So not really nice numbers, but negative 97 over 29 and 18 over 29 is our point of intersection for these two equations.